You just lost 2 marks. Boom. Gone. And you know what? You haven't even finished reading the question yet. This is literally the exact trap that thousands of Cambridge Biology 9700 candidates fall into every single year. Welcome to this explainer. Today, we're tearing down section 15.1, resting potential, maintenance, and changes during action potential. But hey, we're not just going to sit here reading the textbook. No way. We're hacking the mark scheme together. Let's dig right into what principal examiners are actually looking for and find out exactly where those easy marks are slipping away.
All right, let's dive right in. Take a look at this. A flawed 0-mark answer usually leans on a super vague explanation of resting potential. You know the type, maybe just regurgitating generic textbook facts about the sodium-potassium pump. Now, compare that to a top-bend answer. This one uses specific contextual data and incredibly precise terminology that links directly back to the stimulus material. The crazy thing? The student who wrote the flawed answer probably knew the biology perfectly well, but they completely failed the exam technique. They lost the marks before they even realized what specific part of 15.1 the examiner was testing.
So, what's really fascinating here is the core reason behind that failure. When we dug through the examiner reports for Cambridge Biology 9700, a pretty crazy pattern emerged. Section 15.1 is consistently one of the most misunderstood areas in the entire AS and A-level biology syllabus. But why? Well, because the true challenge isn't rote memorization. It's applying those theoretical concepts to completely unfamiliar contexts. Top-performing students, they exhibit a connected conceptual understanding that they can transfer to literally any weird, wonderful, or complex scenario the examiner decides to throw at them. So I have to ask you, why does ordinary revision fail you here? I mean, if you just sit in your room highlighting your notes on voltage-gated channels and that negative 70 millivolt resting membrane potential, why doesn't that guarantee an A-star? It's because Cambridge academic benchmarks prioritize analytical depth over superficial breadth. Simply knowing the biological facts, that's just the baseline. The exam is really testing your cognitive domains, basically how you handle information, evaluate data, and reason through a problem logically. And that brings us to a massive quick win, the method mark strategy. This strategy is all about earning marks for demonstrating the correct analytical process, even if your final answer or calculation is totally flawed. Examiners actually want to see your systematic analysis and your evidence-based reasoning. If you deconstruct the data and evaluate the evidence correctly, you can still salvage crucial marks when your final calculation goes completely off the rails.
So the absolute crucial point here is that you must show you're working always. Now, in just a moment, I'm going to show you an examiner clue that changes an answer completely. But first, you need the framework that makes that clue super obvious. Seriously, if you leave this explainer right now, you're going to miss the absolute secret to unlocking those top band marks. So let's build that framework together.
Section 1, the procedural framework.
Okay, there are 5 mandatory steps to this procedural framework. First up, deconstruct the question. Next, extract the relevant data from the stimulus. Then, select your analytical framework. Finally, execute with clear notation and present your final answer using correct, context-specific terminology. Memorize this exact sequence. It's like a problem-solving engine. It's exactly what you need to break a complex problem into logical steps, solve it systematically, and check for reasonability.
This brilliantly illustrates exactly why the framework matters so much. A blank page with a wrong final answer gets 0 marks. Even if the student had a momentary lapse in mental math, or maybe they just misread a tiny decimal, the examiner has literally nothing to award marks for. But look what happens when logical, step-by-step working is shown based on the framework. Boom, full method marks. It's like a massive red alert straight from the examiners. Method marks can and absolutely will save you. Now, a huge part of handling information in section 15.1 involves comparative analysis. When a question asks you to compare changes during an action potential, you need to mentally draw out a table just like this one. Top-scoring comparative analysis demands identifying similarities and differences. You have to use comparative connectives, support every single point with evidence directly from the graph or data table, and finally, draw conclusions about their relative importance. If you only list similarities, like, say, both cells depolarize, or you forget to include the evidence, your marks are automatically capped.
Okay, time for a quick interactive challenge. I want you to pause and predict. Take a look at this data extraction representing a student's answer about a change in membrane potential. Spot the error. What is fundamentally wrong with how this candidate has presented their data? Go ahead, take 3 seconds.
Did you catch it? Missing units and improper context. The student just wrote down a number.
In biology, especially when we're talking about electrical potentials across a membrane, a number without millivolts or a direction without actually stating whether it's depolarization or hyperpolarization is entirely meaningless. The examiner just cannot give you the mark if you strip the data of its biological context.
Section 2. Top 3 examiner warnings.
So it turns out there are exactly 3 fatal traps that candidates repeatedly fall into. 3 tiny mistakes that will completely derail a top-tier grade, specifically when you're dealing with resting and action potentials.
Here they are. Number 1, using the wrong terminology for the wrong context. Number 2, students simply forgetting to check their units and notation. And number 3, providing answers that are entirely generic and not specific to the unique context given in the exam prompt. You know, you really can't just regurgitate a pre-memorized paragraph about voltage-gated channels. It has to directly answer the specific scenario the examiner just presented to you.
To really lock this in under exam pressure, here is a super powerful memory hack. Whenever you're analyzing factors affecting the resting potential, just remember the acronym CUT: context, units, terminology. Before you move on to the next question, look at your answer and ask yourself, did I match the exact context? Did I include all the correct units? Did I use the precise terminology? Run your answers through that CUT filter and you'll bypass those 3 examiner traps instantly.
This quote, directly from the examiners, pretty much says it all. Top scoring candidates demonstrate evaluative thinking by questioning assumptions and justifying decisions with evidence. This right here is what separates an A from an A star. It isn't just about describing what happens, it is about evaluating the information. You need to look at a graph of an action potential, question the underlying data, consider different perspectives, and justify every single claim you make with hard evidence from the prompt. And you know what? This evaluative thinking is exactly what's tested in the experimental skills portion of 15.1. Practical work requires a rigorous framework too. You have to be able to select the appropriate apparatus, follow sequential instructions to make accurate observations, record your data in suitable tables, identify any anomalies in your results, and draw evidence-based conclusions. If you apply the method mark strategy right here, showing your step-by-step working for how you'd set up the investigation, you secure the maximum marks. Section 3, the final recap. But here's a kind of terrifying thought. What if you do everything we just talked about? What if you execute the method absolutely perfectly, you show all your working, you include your units, you use the right terminology, and you still score 0? Well, the hidden cause behind that is misinterpreting command words. Think about it. If the examiner says evaluate and you just describe, it doesn't matter how perfect your biology is, you lose the marks. The command words actually dictate the mark band, and misreading them is literally the ultimate silent killer in Cambridge biology exams. You absolutely cannot afford to let command words ruin your A star. Ask yourself, are you answering the question the examiner actually asked, or the one you kind of wish they asked? In our next explainer, we are going to decode the exact command words that decide your mark band. Be sure to subscribe to our channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, go practice those past papers, and I will see you in the next session to conquer those command words.